Hello, my math friends. This is Mrs. Schlecht, and in this video, we are going to solve some inequalities. All right, my friends, so you know that before we get going, there's a few materials that you need in order to be successful for this activity. First, you're going to need your Envision book. That's the one with our little robot friend, and we're still in volume 1. Second, you're going to need that math notebook so you can take those beautiful notes and show all your wonderful math thinking. Third, don't forget that pencil so that you have something to write those great notes with. And fourth, last but certainly never least, that positive math attitude. So my friends, this video goes very well with lesson 4-7 in your Envision book, and the key concepts can be found on page 228. So my friends, we've talked about inequalities before. That's like your greater than, less than, equal to. But remember, we also bumped it up a nice notch, and then we added greater than or equal to, less than or equal to signs, right? Now in this lesson, we're still working with those same ideas, but we're going to be looking at some number lines. We're also going to be looking at these inequalities with variables, of course, and figuring out what possible values could those variables have that would make that inequality true. So first, let's look at some number lines. So first, let's look at this inequality. We have f, that's our variable. Don't really know what f is, but I do know that it's greater than 1. And what we're going to do, my friends, is I want to represent this relationship on my number line. So I know we don't know what f is, but I do know where the number 1 is located. And what else do I know about it? Well, I know that the number 1 is not f, but f is going to be bigger than that positive 1. So, I wonder how we could represent that. So you'll notice a couple of things. First, this is not a 0. It might look like a 0, but trust me, it's not a 0, okay? It's supposed to be like a circle, all right? So it's a circle that's not shaded in. You're probably thinking, Mrs. Schlecht, yeah, I can see it's not colored in. Why does that matter? It's going to matter. Just hold that thought, okay? So anyway, it's an open circle. It's not colored in. And notice that I have an arrow that's pointing towards the bigger end of my number line, right? We are all so smart and brilliant and beautiful. We know that our number line would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, all the way up to huge, ginormous numbers, right? I don't know what f is, but I do know that it's bigger than 1. So how do I represent that? Like this. I can say that f is going to be bigger than 1, but it's not 1, right? Because there's no greater than or equal to sign. So I know that f is not 1, but it's bigger than 1. So I represent that by having that open circle. Think of it as all the different possibilities that f could be equal to, right? Now, what if f was going to be less than 1? So now in this example, we still don't know what f is, right? And since f is not equal to 1, notice we still have that open circle. But what changed now is the value of what f could be, all the different possibilities, right? No longer is f going to be bigger than 1. Now we're saying it's less than 1. So I still have that open circle above 1 because, that's the only value we truly know, right? But now my arrow is pointing away from my positive 1, and it's going to get smaller, right? Here are all of our negative numbers in negative number land over here. But that's all going to be smaller than 1, right? And that all has the possibility of being f. So again, we're using this number line, my friends, to represent the relationship between f, which is our variable, that's unknown, and what we do know, which is the number 1. So again, we have an open circle because it's not necessarily equal to it, and then we're pointing this way because it's less than 1. All right, so now some coloring is going to come into play. You're probably wondering, Mrs. Schlecht, you're making a huge deal about an open circle. Yeah, I know I am, because now look at our new inequality sign. F is still less than 1, but it's less than or equal to 1. Now that means that it could possibly be the number 1, but it might not. So how do we represent that? By coloring in our circle. That now tells me that 1 is a possible value of our variable, but it's not the only possible value of our variable, because remember, it's less than or equal to. That or, right? This is the equal to part, but that or, that less than part is over here. Now, I wonder, how would you represent this relationship if it was f is greater than or equal to 1? So my friends, it's that same idea. Notice that we still have that colored in circle dot above 1, because again, 1 is the only like real value that we know. But remember, it's colored in because it's possible that f is equal to 1. It's a possibility, but don't forget about that or, right? It's also possible that f is greater than 1 as well. And we represent that by having that colored in dot, but then our arrow is pointing towards the larger numbers, right? So again, my friends, if it's a circle that's colored in, that means that you have that equal to possibility, right? And then likewise, if it's not colored in, that means that it is not a possible equal to sign, right? Now, let's get into your book. All right, my friends, so the first example from your book that I'd like to look at together is on page 228, and it's number 6. Now, the way that this problem is laid out is it gives us a number line with enough information, but it wants us to then create that inequality. So the variable that we're working with here, my friends, is z. So nice. Now, notice a couple of things. 1, we have an open circle. It's not shaded in. That means that 14, because that's the number that it's right above, 14 is not z, right? If it was a possible substitution for z, it'd be colored in, right? But it's not. Notice which way is that arrow going. It looks like it's going towards some smaller numbers. So what is the relationship between z, which is our unknown, and the number 14? So my friends, this is the inequality that we can use to represent the relationship between z and 14. We know that z, not possibly 14, because our dot is not colored in, but I do know that it's getting smaller. That tells me that whatever z is, it is less than 14. All right, my friends. So the next example that we're going to look at together, still on page 228, number 7. So again, we start with a number line, and then it's asking us to write the inequality that represents this number line, right? That has the same information. So a couple of things you might notice. Hey, check out that dot. It is colored in. That means that 18 is a possible value of d, but it might not be d as well, right? Notice the way that our arrow is moving. That tells us that yes, d could totally be equal to 18, but it could also be 20. It can also be 23, right? So how would we represent this relationship with an inequality? Did you say we would use our greater than or equal to sign? Of course we would. Well done. Now remember, it's greater because our arrow is pointing towards the bigger numbers than 18. But it also has that little equal to possibility because our circle is colored in. So again, D, it could be bigger than 18, but it could also be 18. So we say that it's greater than or equal to 18. All right, my friends, so now we're looking still at page 228, number 9. You'll notice our friendly little number line is bye-bye, but that's okay. So what this problem is asking us to do is look at this inequality. So we have t is greater than 25. And it's asking us to figure out, well, what are the possible values of t then? Remember, we don't really know what t is, but we do know some possibilities of t, right? So let's think. We're looking for numbers that are greater than 25. So is 24 greater than 25? Of course it's not. So see you later, 24. Let's look at 25. Now this might be a little tricky, but not for you because you're brilliant. Is 25 greater than 25? Of course not. They're equal to each other. 25 is 25. They're equal, right? So that's not quite a possible solution for our friendly little letter T over here, right? That leaves us now with 25 and 1/10. Now, think about it this way. Is it true that $25.10 is bigger than just 25? Of course, even though it's not much greater, it's still greater. Therefore, 25 and 1/10, that is a possible solution, a possible value for our little variable over here. Likewise, 27. I don't know about you, but I'm pretty sure that 27 is greater than 25. So for number 9, when it's asking about the possible solutions of t, we all know that out of that variety that it gave us, it's just 25 and 1/10 and 27. All right, so the next problem that we're going to look at together, still on page 228, number 10. Again, no number lines here, but it's asking us to see, well, what are the possible values of g? So we have g is less than or equal to 4, right? So again, we're looking for any number that could possibly be 4. 4 might be the value of g, but it's not going to be bigger than g, right? So let's look. True or false, my friends, is 0 either equal to 4 or less than 4? Of course, it's less than 4. That means that 0 is a possible solution, a possible value for g, so we're going to leave it. Let's look over here. Now we have 4. True or false? Is 4 either less than or equal to 4? Yeah, of course it is, right? Therefore, my friends, we're going to keep that 4 around. Now, let's look at 5. Is 5 either equal to 4 or less than 4? Of course not. Therefore, we're getting rid of it. All right, let's look at number 6. Is it true or false that 6 is either less than 4 or equal to 4? Of course not. So for problem number 10, the only two possible values, at least from the ones that they listed and gave to us, are 0 and 4, because these are the only two numbers that it gave to us that are either equal to 4 or less than 4. All right, my friends, so the last one that we're going to look at together, yeah, it's still on page 228, number 11 this time. Now, we have y, and that's either greater than or equal to 8. And again, we're trying to find then possible solutions or possible values of our variable y. So let's think about this. We're looking for numbers, again, that are either bigger than 8 or 8 itself. Now, I'm sure you're thinking, Mrs. Schlecht, 4, 5, 6, and 7, those are all less than 8, and we're looking for numbers that are bigger than 8. So are any of these a possible solution or a possible value for y? Of course not. We got rid of all of them. So for number 11, my friends, all of those different options that it gave you, well, none of those would make this inequality true. But I wonder what numbers would make this inequality true. These are just some of the few examples that would make this inequality true. Remember, when we have a greater than or equal to sign, that means that y, it could very well be the number 8. But it could also be any number bigger than 8, 11, 105, 8.5, tons of different possibilities. All right, my friends. So again, that was just a quick run through with more inequalities and looking at them on number lines and trying to solve them. Of course, if you have any other questions, please let me know.